blockchain hacks, crypto hacks, cybercrime. That's what we're going to talk about today. And people have asked me for that. So in my previous videos, people were asking, hey, Bernie, please tell us about how exactly those hacks happen and how those guys do it. So thanks for the tip. I'm doing this video now. I'm Blockchain Bernie, live streaming 3 times a week. If you like content like this, please give me a like. It doesn't hurt, I promise, and it's so good for the YouTube algorithm, and it will really help me out, so thanks in advance. Those blockchain hacks, I have 3 prepared for you today. And, there's a long history, obviously, of those hacks, and hacks happen everywhere, right? Also in regular banks, it's not crypto specific, not blockchain specific, not anything. It happens everywhere, but blockchain hacks, crypto hacks are quite interesting because they happen in code and they happen in the brain. So let's dive into it. The first one that happened was back in 2010, and it was a hack on Bitcoin, right? So believe it or not, there are people out there that say, well, Bitcoin is the only true thing and, the only thing that's safe. But what happened in really early days of Bitcoin, someone created 184 billion BTC, right? And that was in 2010. And how did that happen? I mean, it was an integer overflow error, right? So if you're like me and, started your programming career with, really restricted hardware and stuff like that, you know that, on the hardware level, integer additions can overflow, right? It's just you need to program it in software. So I grew up with 16-bit arithmetic. So let's say 16-bit, right? In 16 bits, you can have numbers from 0 to 65,535. And if you have that maximum number, 65,535, and you add 1 to it, then it goes back to 0. It is a little bit like the odometer in your car. I mean, the old odometers that were mechanic, like after 99,000 miles or so, right, in the really old cars, it went back to 0, right? And then they made it 6 figures at some point in time. So it would need like 99,999 miles, and then it goes back to 0. And the same thing happens with computers, and they all do it binary, right? So 65,536, that would be 16 ones, right? And then you have the 16 ones, and then it, overflows into 16 zeros. So what these guys did on Bitcoin is they had a small amount of money, right? Like a tiny amount of Bitcoin, and they just sent it to 2 other addresses that add up to that 184 billion. 184 billion is the largest number that you can put in 64 bits, right? Because those BTC numbers, they're encoded in 64 bits, and 100 million Satoshis is 1 Bitcoin. So you have to take 2 to the power of 64 and then divide it by 100 million, because that's the number of Satoshis in 1 Bitcoin, right? And then you arrive at those 184 billion. And obviously that could have never happened because there's only supposed to be 21 million Bitcoins ever, right? So they recognized that thing very quickly, and it was simply a bug in the actual Bitcoin software, and they didn't check for overflows in integer arithmetic, right? So that guy was able to exploit that, right? And he just said, okay, I have, a couple of Satoshis, a very small amount. And then he put like 2 times 92 billion into 2 different addresses. And then the code and the Bitcoin added those 2 up, and it came to 184 billion. But since it was a signed integer, that was like a small negative amount. and they thought that is okay. It passes all the tests because it's a little bit less than he had before, and the difference might be fees, right? So that was a bad bug in the early days in the Bitcoin code, and it has been exploited, right? And then what happened is that Satoshi Nakamoto himself, together with one other guy, just fixed that bug and persuaded each and every miner, which were, few miners back in the day. We're talking 2010, right? He persuaded them all, and then they did a fork, and that way this guy, hasn't hadn't his bounty was kind of invalidated, right? So that was an early hack, and it was just a bug in the code, right? And as with all computer code, it's kind of impossible. It is if it has like a minimum complexity and it really changes the world, you can do stuff to minimize the probability of bugs, like code reviews and stuff like that. Probably in the early days of Bitcoin, there didn't happen that many code reviews, right? He put it on the internet, and some other guys could read the code on GitHub and stuff like that, but there were no formalized code reviews and stuff. Formalized code reviews are really cool stuff. So if you have the opportunity and the resources to do that in larger companies, it's kind of standard, but also in smaller companies or in your private projects, do formal code reviews. Look it up on Google, how it's being done. It is great stuff. And it probably, yeah, in any serious code review, that thing must have come up before it was exploited, right? But it was exploited, and they were able to mitigate it just because, Bitcoin was so new back in the day, and Satoshi, as the creator of Bitcoin, he had the persuasion power to persuade a few of the miners to do that hard fork, right? So yeah, there are so many Bitcoin maximalists out there that say it's the only safe thing and the only sound money and stuff like that. If you know me, I'm not a real fan of this. Of course, I like Bitcoin and I think it has a bright future, but it's not like, Bitcoin's the only thing that was never hacked and stuff like that. It's just not true, right? So the next hack I'm going to talk about is it happened on June 17th, 2015. So that was a very different thing. Let's go to the next tab here. There was an article even on June 16th, 2016, warning about it. And that was an Ethereum bug, right? And in Ethereum, back in the day, we had a thing called the DAO, right? DAO stands for Distributed Autonomous Organization. And it was that big thing, and it was kind of a decentralized venture fund and stuff like that. So everyone could send their ETH tokens into that smart contract, and they got the DAO tokens in return. And with the DAO tokens, they could vote for projects that get venture funding from that fund and stuff like that. And this whole thing was stricken with lots and lots of vulnerabilities. From day one. The poor guy that wrote that code is called Christoph Jensch. Here he is with his brothers, two German brothers, obviously from Saxony, Germany. And here's an article in the New York Times from back in the day, 2016. That was just before the hack here, right? So they wrote about these two guys here. You can see that here, right? New York Times, yeah, and that was from May 17th, 2016. So here are the poor guys that wrote that code, and what was in the code? It was a so-called re-entrancy issue. So what they did is like if the code in the DAO had a function for people to get back their ETH that they invested into that a DAO contract. So you could get it back, but then the programmers, so Christoph Jensch, didn't really think about what happens when the next guy calls the code when the code for the first guy hasn't finished yet, right? Then kind of two instances of the code run at the same time. And I've already made a few videos about the Rust programming language, which is specifically made to reduce the probability of these errors, right? It's kind of a safe language for reentrancy and all that kind of stuff, right? With Ethereum and Solidity, the programming language that's being used for the EVM, the Ethereum Virtual Machine, it's not that safe with reentrancy and stuff like that. So the programmer has to take care of that and has to make sure that, you know, when he writes into a variable, that he keeps in mind that I'm not the only one owning this variable, because there could be a second instance of my program running in parallel and writing to that same variable, right? So you don't want these type of things to happen. And with Rust, this is going to be checked by default. And also with Solana, with the Solana runtime system, you don't even have those variables, right? You either have local variables that you really own, and each instance of your code running has their own, right? Or if you have some global state that you're manipulating, you have to create a Solana account and you have it explicit, right? And then if you write to it, you have to declare that you write to it, and then the Solana runtime will sequentialize it and will not allow these clashes where we have data dependencies, right? So in that respect, the Solidity and Ethereum virtual machine is inferior to what we have in Solana, and also the Solidity language is inferior to Rust. With not, it's not a general judgment, right? But just regarding these things that can happen and make these bugs possible, right? So now people saw the code on GitHub, and these guys here that I was showing you, the hacking distributed, and that's written by a bunch of guys here, and they already warned about that vulnerability before it was being exploited, right? And the next day, actually, this article was published June 16th, 2016, and the next day it was really exploited, and it was $70 million worth of ETH that was exploited from that contract. They couldn't really cash out because by design, it went into an account that was locked up for 28 days. And during those 28 days, they could fork the Ethereum chain. And that's the reason we have Ethereum Classic these days, right? On Ethereum Classic, these hackers still have their funds in Ethereum Classic, right? And that chain is living on. And it's an okay blockchain. It's not like a criminal chain or anything. It's just that, you know, this hacker, we don't know who it is. He has those funds in Ethereum Classic, right? But the Ethereum community didn't want that to happen, obviously. So they did a hard fork as well, and they just forked the Ethereum chain. And it's important to understand that the bug was not on the Ethereum chain, right? The bug was in that smart contract. And the smart contract just wrote to a variable, oh, I've paid it out, you know, and then, but when you call it fast enough, you know, it will run in parallel. And then they didn't check whether this variable has been written by this instance or by the other instance. So through that, they were able to withdraw their funds multiple times faster than the code could, you know, do the bookkeeping about it, right? So that's another, you know, one was the integer overflow. You know, it's, yeah, it happens all the time. So in each and every code, if it's, you know, code that's close to the machine, and that happens in blockchain, right? We want to have efficient code in blockchain. We cannot afford to use those super high level programming languages that are not so performant, right? We need to be performant. So we do fast code, but then we have to do all the checks manually, right? We cannot rely on some super high level programming language to do that stuff for us, because that would take too much time and would cost us too much performance. All right, that was the second one. And the third one I have for you is the largest in history that ever happened. And that one's relatively recent. It happened on March 23rd, 2022. And here it is. It is about the Axie Infinity, a very popular play to earn game, very popular in countries like the Philippines, other countries as well. Many people play that game and sell their assets that they create in the game to other people, so they earn money with it. And yeah, it was kind of you know they were able to hack $650 million, right? And what they did is they hacked the Ronin chain, right? So Ronin is a side chain of Ethereum, and for some reason, the Axie Infinitor inventors, they wanted to build it on Ethereum. I'm a big fan of Solana. It all wouldn't have happened on Solana, but they build it on Ethereum. And since they cannot really do it on Ethereum because it's not fast enough, they had to create their own network, kind of a side chain on Ethereum, so that transactions are cheap and fast and stuff like that. But this side chain, they designed it with very few validators. It was not really decentralized. So then what happened with that Axie Infinity hack, it was like social engineering, right? Somehow through social engineering, the hackers were able to get the private keys of some validators. And all they needed was access to 5 validators. Can you believe it? Right? So they had billions of dollars in there, and it was not really decentralized. And 5 validators are enough to compromise the network, right? So let's compare that with modern networks. And, there is the so-called Nakamoto coefficient, that measures how many validators you need to compromise the network. Solana, by the way, has one of the highest Nakamoto coefficients. So by that measure, it's one of the most decentralized blockchains out there. But with the Ronin network, a sidechain of Ethereum, they only needed 5 validators, right? So they kind of did some social engineering is like, someone, or you call someone and you pose as, the security department or stuff like that on the telephone, and someone gives you access, right? So that's how it happened. And they got access to 5 validators. They could compromise the whole Ronin chain and, send all the ETH and USDC stable coins into their own wallets, right? All the users got reimbursed afterwards by Axie Infinity. Axie Infinity raised some more money from their investors and crowdfunders and stuff like that. So everyone got reimbursed, but obviously it took a big hit to that whole Axie Infinity game. Yeah, so this is how these things can happen. It can be problems in the code. It can be as simple as integer overflows in integer arithmetic. It can be, more subtle things, as not being able to be reentrant in the code, right, or handle parallelism adequately, right, which is a little bit more subtle thing when you code, right? It's not your primary concern when you write your code in the beginning, right? But you have to, as a programmer, you have to take care of these things. Also, that could have been found by code reviews. And then social engineering is everywhere. And social engineering, whether it's in crypto or in any other field, it is a big risk, right? So yeah, here was my overview on how this all could have happened. Don't forget to give me that like button, subscribe to my channel. There will be more, and I promise I will give you more insights on some of those more hacks in future videos. So hit the bell notification when you subscribe, also the bell notification so that you won't miss any of my future videos. Thanks for watching. I appreciate you so much, and catch you later.